Hello students, welcome to today's lecture. We are still continuing with types of material, and today we would like to discuss about steels. So steels is an alloy of carbon and iron, and the percentage of carbon goes to up to a maximum of 1.7%. So the carbon occurs in the form of iron carbide because of its ability to increase the hardness and strength of the steel. There are other elements that are used in the making up steel which are mixed with iron other than carbon. These elements include silicon, sulfur, phosphorus, and manganese. And we will discuss the effect of adding these elements in the next class. So let's see how the properties of the carbon content varies the property of steel. So the figure 4.3 here shows the effect of carbon on the properties of steel. So as you can see, the carbon content ranges from 0 to 1.2%, and the ultimate tensile strength on the left hand side ranges from 20 to 60, and the Brinell hardness ranges from 100 to 300. So as you can see, if we have low percentage of carbon, then that form of steel is called ferrite steel, and some of it can also be called, most of the percentage, the bigger percentage is ferrite, but the smaller percentage is pearlite. So what is the effect of having low carbon content in the steel? So that will make the steel to be more ductile. As you can see, the ductility graph, it is highest about 53% of tensile strength. Then it decreases, the ductility decreases as we increase the carbon content up to 0.8% of carbon. Then what about the Brinell hardness? At low percentage of carbon, the Brinell hardness is less. It's as nearly 50 Brinell hardness. But as we increase the carbon content up to 1.2%, the Brinell hardness increases up to 280. What about the ultimate tensile strength? The tensile strength is the strength that exists if you try to stretch the steel material by pulling it into a part. Then it will exhibit the resultant force that try to oppose those pulling forces is what is called the tensile strength. So the tensile strength, as we increase the percentage of carbon, it increases gradually up to 0.9% of carbon. Then it starts to decrease up to, for our graph here, it goes up to 1.2% of carbon, give us tensile strength of 55. But that of 1 to 1.1 give us tensile strength of 56. So we see that the tensile strength is greatest at percentage of carbon of 1 to 1.1%. So let's see the grains, the behavior of the microstructure for different steel elements. So we'll start with the ferrite grain. As you can see, the ferrite grain is bigger crystals, and there is no carbon element added to it. So when we begin to add carbon element, the ferrite grain changes its composition to be called pearlite, and now that percentage of carbon is 0.3% that constitute to pearlite structure. Then the ferrite, as we increase more of carbon to make it dense, then up to about 6.6%, then the structure changes from pearlite to ferrite, which has now smaller crystals. So at a percentage of 0.83% of carbon, you can see how dense the structure is. So this marks the end of our today's lesson. Let's meet again in the next class.